Day 146, Physics Circuits Homework, Problem 1A. We're asked to simplify the circuit and find the overall equivalent resistance of all four of these resistors, and then find the current that will be supplied from the battery. This requires a bunch of diagrams. The most difficult part of this for beginners is finding out where to start, or determining where to start. Where are the parallel and series portions of the circuit? Well, the 50 and the 40 here are in parallel. If you're at this spot right here that I'm highlighting, there are only two ways to get from that spot to this spot. So you could go up and around to get to that spot, or you can go down and around to get to that spot. We call that point A and this point B. There's two pathways. Those are obviously in parallel. And the way you combine those is by that 1/over relationship. In other words, it is 1/, hang on, 1/, the total resistance of those two resistors combined equals 1/40 plus 1/50 ohms. I'll do the math there, and I'm going to draw the diagram as well. So that comes out to be 22 ohms when you combine those. And the new diagram will look as follows. So I've drawn the new diagram over here. The 30 ohm resistor is still in the same spot, but I've replaced this 40 and 50 that were in parallel with their equivalent resistance of 22 ohms. I still have the 60 here. I still have the 100 volt battery. You might want to pause the video and draw this. Right now, if I'm at point A and I'm trying to get to point B, there are two ways to get there. So once again, I have a parallel situation. However, within this branch right here, this pathway from A to B, there are two consecutive resistors, and we say that those are in series. So I'm going to combine those first before I do the parallel, and it's simple addition here. 30 plus 22 gives me 52. I'll draw that diagram. And there we have the diagram. I've replaced the 30 and the 22 with a 52 because they were in series. And I still have location A here and location B, which I have not labeled right now, but we can hopefully see that the 52 and the 60 are in parallel. There are two different pathways to get from this point A around to point B and then back to the battery. So I'm going to use the rule as I have on here on the left, the rule for combining resistors in parallel, and that is 1/R total is 1/52 ohms plus 1/60 ohms. Go to your calculator. You might want to pause the video and do the math yourself to check it. And I'm getting 28 ohms when you combine those two. So then you just draw the last diagram, which would be your battery, 100 volt battery, and your final diagram, which has a total combined resistance of 28 ohms. In other words, all four of those resistors together are acting like they're a single 28 ohm resistor. So I've got half my answer here way up in the top. My R total right up here is 28 ohms. So I put that in there, 28 ohms. And now I'm going to use V equals IR. So like I said, I have my V equals IR Ohm's law. I have 100 volts equals I times the resistance of 28 ohms. It will be 3-point-something. 3.6 amps. And that is my circuit current, my total current that my battery is supplying. I can go up to the top here, 3.6 amps. That's all we need to do for that problem. If you needed to do more for more advanced classes, bottom line is that current, which is flowing through this simplified circuit down here on the right, 3.6 amps, not starting from the battery but flowing everywhere all the time. What's happening is that current is coming around to this point here and splitting up. About half and half because they're almost equal resistors, but a little bit more than half of that current will go through this branch and a little bit less than half through that branch and flow around. but we don't need to calculate that today. We've accomplished the task for this particular problem.